Okay, here we go. We were talking about rational functions. The inverse variation function y equals 1 over x is an example of a rational function, and it's actually the parent function. So in red here, I have the graph of the parent function is called a hyperbola, which consists of two symmetrical parts called branches. The domain and range will be all real numbers except 0. Now this is true for the parent function. Now if you want to draw or graph a hyperbola, step 1, you start with the vertical and horizontal asymptote. So in this form, the horizontal asymptote, you set the denominator equal to 0. The horizontal asymptote is y equals k. So let's write this up here. The horizontal asymptote in general is y equals k. The vertical asymptote will be where x minus h equals 0 or x equals h. So in this one, there is no plus k, so the horizontal asymptote is y equals 0. Step 2, here's what you're going to do. You're going to plot 3 points to the left and 3 points to the right of the vertical asymptote. If the vertical asymptote is x equals 1, we're going to go 1, 2, 3, negative 1, negative 2, negative 3. On this particular problem, we should be able to do it without a calculator. If I plug in to y equals 1 over x, 1 over 1 is 1. 1 over 2 is 1/2. 1 over 3 is 1/3. Now when I plug in x is negative 1, I get 1 over negative 1. I get 1 over negative 2, which is negative 1/2. And if I plug in 1 over negative 3, it's negative 1/3. So I'm going to make my coordinate grid. Now what you want to do, just like we did with exponential functions and logarithmic functions, before you plot your points, draw the vertical and horizontal asymptotes. So I have a horizontal asymptote of y equals 0. And you guys make sure it's dashed enough that I can see it, because if I can't see it, unfortunately, I have to take points off. Now I'm going to plot my points. I have 1, 1, 2, 1/2, 3, 1/3. And then step 3 says to draw the branches of the hyperbola so they pass through the plotted points and approach the asymptotes. Here's 1, negative 1, negative 2, negative 1/2, negative 3, negative 1/3. So this is the parent function for 1 over x. Okay, any questions on that? All right, example 1 says graph the function y equals 6 over x and compare it to the graph of y equals 1 over x. Well, my horizontal asymptote, there's no k value, so the horizontal asymptote is y equals 0. The vertical asymptote, you set the denominator equal to 0. And then what I told you in the steps, my requirement is you plot 3 points to the left and 3 points to the right. And so you guys, when it starts to shift, and we're going to do the left, right, up, down, stretch, shrink it, flip it. We're going to do all that. The vertical asymptote will change, and we're going to see sometimes you have two vertical asymptotes. So you're going to have a lot more points to go. Okay, so here we go. If I have y equals 6 over x, 6 over 1 is 6. 6 divided by 2 is 3. 6 divided by 3 is 2. What do you think putting a negative in front? It just makes them negative. So we've already done the work. Graph your horizontal asymptote and your vertical asymptote. Alright, I am going to attempt to go by ones, and I'm just going to extend it down a little bit. So here's 1 comma 6, 2 comma 3, and 3 comma 2. So what I want you to notice is that it's going to take a little bit of time to get it to approach. So you need to take care, and I guess, you know, when I hear you guys say you don't like to do graphing, is these do take a lot of effort. And that's a good thing for us, is to spend time and energy on this and putting detail in. So as you're drawing this going to the right, you have to kind of keep going a while to get it to start. I like to call it hugging the asymptotes. All right, then I have -1, -6. I'm just going to go down one more spot on my grid. Here's 2, -3. And then if you notice, I'm going to need to extend that just a little bit. And so sometimes you do have to go back and extend your asymptote, and that's okay. So how does this one compare? I'm not sure you can see it real well. Anybody? Noah?
Stretch.
Yeah. Do you see that 6 over x is actually equal to 6 times the 1 over x? So this is a vertical stretch. We didn't talk about this on the last one, but let's go ahead and talk about it now. Let's talk domain and range. The domain, do you notice x can't be 0 because you would divide by 0. So the domain is all real numbers except 0. Now the range are the y values. This is going down to -infinity, but it comes up and it doesn't touch y is 0. And then here it's up to +infinity and it comes as close to 0 without touching it. So the range is all real numbers except 0. Now I need to tell you something, and as you guys are going to forget this because every year students do. A vertical asymptote is never ever crossed or touched. However, a horizontal asymptote, you guys can't quite handle the real definition of it yet. You can't handle it till you get to calculus, and it has to do with a limit. I'm going to mention it and plant some calculus seeds right now. But the formal definition of a horizontal asymptote is as x approaches infinity, what is the limit of the function? What's the intended height? So a horizontal asymptote is only talking about far to the right and far to the left. A horizontal asymptote can get crossed in the middle of the graph. So let me say it again. A vertical asymptote is never ever crossed, but a horizontal asymptote may get crossed in the middle, but it doesn't get crossed when you want to go far out to infinity or -infinity. Okay? All right, now what if we have translations? We can do this a couple different ways. This one says you can do y equals 1 over x and then shift h to the right, k up. We're not going to do that. We're going to start with our horizontal and vertical asymptotes and just make our table. I think it'll be fine from there. So let's look at example 2. It says if we want to graph y equals negative 4 over x plus 2 minus 1, the horizontal asymptote is y equals k. So in this case, it's going to be y equals negative 1. The vertical asymptote, you have to set the denominator of your fraction equal to 0. So my vertical asymptote is x equals negative 2. All right, now here's where the table gets a little tricky. What I've said to you is you move 3 points to the right, 3 points to the left. So I'm going to go negative 1, 0, 1. That's to the right. And if I go left, it's negative 3, negative 4, negative 5. You should be able to do these without a calculator. It's just, a little bit of work, but we can do it. So if I plug in that x is negative 1, that's negative 4 over 1. That's negative 4 minus 1. That's negative 5. If I plug in 0, that's negative 4 over 2 minus 1. Negative 2 minus 1 is negative 3. All right, what if we plug in 1? That's negative 4 thirds minus 1. Okay, negative 4 thirds is negative 1 and 1 third, right? So this is like negative 2 and 1 third. Let's plug in negative 3. So I get negative 4 over negative 3 plus 2 minus 1. That's negative 4 over negative 1, which is 4. 4 minus 1 is 3. Now let's try in negative 4. Negative 4 over negative 4 plus 2 minus 1. That's negative 4 over negative 2. That's 2 minus 1 is 1. And one more. Negative 4 over negative 5 plus 2 minus 1. That's negative 4 over negative 3. That's 4 thirds minus 1. Isn't that 1 third? So do you see how I can do that without a calculator? And now you need to think about it before you make your grid. So, these graphs are so rich in mathematics. It really does take a lot of mental work. I'm needing to go to negative 5, so I'm going to slide the y-axis to the right. And I need to go all the way down to negative 5 and up to positive 3. So, do you guys understand what I mean about thinking about where to make the coordinate grid? I need more to the left, I need more down. Now, let's do our asymptotes. I have a vertical asymptote at x is negative 2. And I have a horizontal asymptote at y is negative 1. So they're not always the x-axis and y-axis. It depends on our shift. And then let's plot the points. I have negative 1, negative 5. I have 0, negative 3. And I had 1, comma, negative 2 and a third. And notice you're going to draw that branch of the hyperbola, trying to make it hug the asymptotes. Then I have negative 3, up 3. I have negative 4, positive 1. And I have negative 5, 1 third. Now, a question I have for you, even though we don't see it, is it going to cross the x-axis? Yes, because it's got to hug that horizontal asymptote. So what you want to do is, we don't know where it is. without doing a little bit more work, but make sure you show it's going to cross it to approach that horizontal asymptote. So this isn't bad, but it is long. You know, it's a lot of work, but it's not like horrible. Now let's talk domain and range. Domain are the possible values you can plug in for x. Because this is a fraction, it just can't have 0 in the denominator. So it's everything except -2, because -2 plus 2 would make me divide by 0. Now the range, I have to warn you, the range is not always y can't be the horizontal asymptote, because sometimes we're going to get it to cross, and we will see that eventually. But for now, it just is not -1. And make sure you're using the right letters, okay? Alright, we're going to skip example 3 just because of time, and maybe on Monday we'll do that one. Now, rational functions can also be written in a second form. And so this is where it's going to get a little gray for us. It's like, okay, now you just told me how to do the vertical asymptote and horizontal asymptote, and now I'm going to tell you something differently because it's a different form. If I have my rational function, y equals ax plus b over cx plus d, it's also a hyperbola. The vertical asymptote you still find by setting the denominator, set the denominator equal to 0. However, the horizontal asymptote, there's no k. There's no plus k. There's a different way to do this. The horizontal asymptote will be the coefficients of the x terms. So let me give you an example here. If I said to you, I have y equals 3x plus 5 over 7x minus 1. My horizontal asymptote is y equals 3 over 7. Okay, it's actually very easy, but you've got to remember it is the problem.
And if you can reduce that, you reduce it?
Absolutely. Like if it had been 3 over 6, we would have said y equals 1/2, yes. Now watch this one. What if I give you 1 minus 2x over 3x plus 8? Let's make sure we understand what I was saying. What would be the horizontal asymptote then?
-2/3.
Awesome. Okay, I didn't trick anybody then. It's the coefficients of the x's, and if there's a minus in front, there's a minus. So good job on that one. Okay, so let's try to do one graph like this. Again, you always want to start with your vertical and horizontal asymptotes. So what is my horizontal asymptote on this one? 2, because it's 2 over 1. The vertical asymptote is the same. You still set the denominator equal to 0. And then you make a table of values, 3 to the right, 3 to the left. So I'm going to go 4, 5, 6, 2, 1, 0. Again, try to be able to do this without a calculator. In AP Calculus, half of the exam is no calculator. So we need to be able to do some of this stuff. So here we go. Y is 2x plus 1 over x minus 3. So this is y equals 4 times 2 is 8 plus 1 is 9 over 1. Okay, that's not bad. 5 times 2 is 10 plus 1 is 11 over 2. Isn't that 5.5? 6 times 2 is 12 plus 1 is 13 over 3. So that's what, 4 1/3? Now let's plug in the 2. 2 times 2 is 4 plus 1 is 5, but that's over -1. So that's -5. If I plug in a 1, 2 plus 1 is 3 over -2. That's -1.5. And if I plug in 0, that's 1 over -3 or -1/3. Alright, so think about your grid. I have a lot of positive x values, so I'm going to slide the y-axis to the, the y-axis to the left. Now, I have a lot going up and down, so we're not going to be able to go by ones, I don't think. We'll try. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Yeah, let's go by ones. I think we can just guesstimate where one more up is. Alright, draw your asymptotes. I have a vertical asymptote at x is 3. I have a horizontal asymptote at y is 2. And here we go. 4, 9. 5, 5 and a half. 6, 4 and 1/3. Now, do you notice that's really far from my horizontal asymptote, so I might need to extend it to make it look like it's going to hug. And then let's go get the other side. I have 2, -5, 1, -1 and a half. Now, this is definitely going to cross the x-axis again, but I'm going to need to extend this. So my domain would be all real numbers except 3, and in this case the range is y, all real numbers y except 2. Alright, go ahead and try example 5 on your own. I'll give you a head start. On your mark, set, go. And I'm going to race you. Just kidding.
And that's how everyone gets everything wrong.
I did go by 2's on my y-axis, so be careful with that. So remember, if you have to go back and extend asymptotes, you just extend it after the fact. It's okay. So when you're done, check it with mine.